Viterbi code. So here we will do the same thing. We will do the same thing considering the received code. In the received code position, we will consider 0, 0 for all cases. Okay. We will consider 0, 0. So I can show you that. Hold a second. Okay, so I'm just showing you the previous lecture from the previous PDF. So this is my Viterbi algorithm. So from this Viterbi algorithm, you can see that this was my received code. That is 1101 and 10. So every time I have considered for the first segment this is 11, for the second segment this is 01, and for the third segment this is 10. And every time I've considered the corresponding output, that is 11. You can see from when I'm going from A0 to A1 and B1, so corresponding output is 00 and 11, and every time I'm calculating the Hamming distance between this received code and the output. So that's what I'm trying to say, that for this 11 and 11, this is the Hamming distance, this was the Hamming distance. So in this way, so this is for the example, okay. But what I have to do in case of calculating the minimum Hamming distance, we have to consider this position as 00, 0. Okay, every time we have to consider 00, 0 and the corresponding outputs, and the corresponding output will be written as same as this above the lines, above the directional lines, and we have to calculate the Hamming distance of this outputs with respect to 00, 0 all the time. Okay, so from the book you can see that this is 00, 0, this is 00, 0, all are the 00s. Okay, so when I'm considering, actually you can see that here it's written that determine the minimum free distance of the convolutional code COM2 and 2 used in the previous example by employing the above procedure implemented over the corresponding trellis. Okay, so we have to first make this CONF2 and 2 trellis. I've already made so this was my trellis. Okay, then the thing is that the sequence corresponding to the path described the sequence, you know that the sequence corresponding to the path described by the sequence of the state, that is SA, SB, SC, SA, seen in pole time. Because you have to keep in mind always, I have told you that for calculating the minimum Hamming distance, you have to starting from all 0 state and back, you have to arrive at all 0 state. So whether this is a state diagram procedure, whether this is a trellis diagram procedure, you have to always keep in mind that you have to starting from SA and coming back to the SA. So SA to SA. So here SA, SB, SC, SA. So from the diagram, you can see that from SA, that means this point, right? SA, SB, SC, because this is corresponding to the C. So this is SC, and again back to SA. So this is one path. Okay. Now the another path is SA, SB, SA. That means SA. So the thing is that what I have to do, that we have to add the Hamming distances. We have to add the Hamming distances, and the Hamming distances is being calculated between this 00, 0 and corresponding output, right? The corresponding output. Why this is 2 is written. It is basically the Hamming distance. Okay. So this is the Hamming distance between 00, 0 and the corresponding output when the present state was 0 0 and the next state was 1 0. I'm showing, just keep in mind that SA equals to 0 0 and SB equals to 1 0. So the next state is 1 0, right? So I'm coming from 0 0 to 1 0. Okay, that means SA to SB. So I have to see what was the output. What was the output? From SA to SB, the output was 1 1, right? From SA to SB, the output was 1 1. Okay. Now, if this is 1 1, then if this is 1 1, right, the output is 1 1. So this is 1 and this is 1, because every time I have written all the outputs, okay, corresponding outputs above the transition directional lines, okay, like this. From this we can see that this is 1 1, this is 0 0. So these are all the outputs of the transitions, okay, and we have considered this is as 0 0. And what is the Hamming distance? What is the Hamming distance between this 0 0 and this output? 2, because there is 2 dissimilarities of bits, so that's why Hamming distance is 2. Now again, when I'm coming from SB to SC, what is the output? What is the output? SB to SC, okay, output was 0 1. So this is 0 1. When I'm coming from SB to SC, this is 0 1. So again, so this is one segment, this is also one segment. So if this is 0 1, then what is the Hamming distance between 0 0 and 0 1? 1. So this is 1. Again, when I'm considering this segment from SC to SA, from SC to SA, what was the point? From SC to SA, from SC, you know that, you can see from SC to SA, the output is 1 1. So from SC to SA, output is 1 1, and the Hamming distance between 0 0 and 1 1 is 2, right? So why I am following this path, because I have to keep in mind that we have to start from all 0 state SA and you have to come back to SA again. So that's why I'm just considering this path, okay? And this is the corresponding outputs, and I'm calculating the Hamming distance between this 0 0 and the corresponding outputs, okay? Or you can say what I've told you before, that when the convolutional code is linear, the Hamming distance, when the Hamming distance is being calculated with respect to all 0 code, then that will be equal to the weight of the code. Or you can say, when I am calculating the Hamming distance between all 0 code and the output, so that Hamming distance will be equal to the weight of the output. I'm repeating again, when I'm calculating the Hamming distance between all 0 code and the output, then that is basically 2, and that is equal to that will be equal to